Welcome, everybody. Tonight we're working on Unit 8, which is part 2 of unsupervised learning. What we're going to be looking at tonight are a few different things that you can see listed on the screens here. We're basically looking at recommendation systems and what they are and how they work. It's kind of interesting. Some of the content is, I think, pretty fun. At least the guy that put the PowerPoint together thought so. We'll look at some of the math that drives it, which is mostly matrix factorization, what that even means, and singular value decomposition that is related to it. And then we'll do a comparison between content and collaborative based filtering. All right. I have the PowerPoint queued up here, so I am going to go into present mode here and swap my screens like I usually do and do a little bit of arranging on the other screen so I can see your faces. And we will get started. All right, so this is the basic agenda for the PowerPoint. Matches loosely with the topics that I typed in the course. But you can see the focus is on recommendation system, but it's really about the kind of like the math and the techniques and how those work, and the logic behind them, because I think it helps to clarify a lot about these models. All right, it says, first, let's understand why we require a recommendation system. And I think require is kind of an interesting word here. But there's a bunch of different things that we interact with, especially online, where this comes into play. And I'll tell you what, some of the companies that we'll talk about are companies that we all affiliate with or have done business with or actively do business with. And I like some of the recommendation systems and dislike some of them. And I'll point those out as I kind of go along. And I think it's really interesting because, like when you go to a website, so there's got to be some algorithm for why Netflix is putting this on my screen. And that's not even something I want to see, that kind of thing. So this might help to demystify a little bit of that. All right. So there's some benefits here with recommendation engines, and it says improving with use. So and they use the word retention here because they want to keep you as a customer, right? Is one of the things. So it says one of the benefits is these systems is their ability to calibrate to the user's preferences continuously. Okay, so hopefully that's true, right? And it improves retention by making products more and more sticky as time passes. So, for example, if I ordered my dog waste cleanup bags from Amazon, it would probably run some algorithm and figure out how soon it would take for me to use those bags up and then recommend that I buy them again, when I'm running out, that type of thing. All right, so they're going to use an example. It says you're much less likely to switch to a Netflix competitor when Netflix has such a wonderful sense of what you like to watch, right? And actually, I'm going to say that I don't think so. I have issue with their recommendation system in a few different ways. They used to have a thing in the past, and I don't know if you guys remember this. Now, if you watch something, you either like it or dislike it, right? And then that drives what other stuff. And what I discovered is I never click either one of them. I never like or dislike anything, right? Because I want it to be neutral in what it presents me, but it still looks at what you watched. Right. It says most of the revenue comes from a fixed rate recurring bill. Okay, so you sign up, your credit card's on file. They bill you every month, right? And hopefully you keep doing that. And you know what? I think I've been a continuous subscriber now for almost since, oh my God, a long time. I'll just put it like that. Like back from the days when they used to send me DVDs in the mail. And I still have a couple of them that never got returned, by the way. I don't know what they never asked for them back is what happened. We lost them, whatever. Doesn't matter. I'm sure they made their money. All right. So that's kind of their thing. Another kind of interesting thing. So it says improving cart value. It says a company with thousands and thousands would be hard pressed and to hard code product suggestion for all of its products. So in other words, like if I go to a place and I buy, I don't know, a pair of headphones, they might sell me an accessory for the headphones, and they would hard code that into the listing, right? So what happens if like you hard code it into the listing and then a new better product comes along that's not included? Well, that doesn't make sense. So they never they never want to take recommendations and directly attach them to a product because then it's stuck there, right? And if better things come out, you're going to miss it. So they want that to be dynamic. So they use what it says by using various means of filtering, the e-commerce people have found ways to suggest, you know, um, either on the website as you're looking at something or an email message or maybe even a text message or something, that new products that you're likely to buy, right? So if they notice that I'm always buying like the newest iPhone when it comes out, Apple might send me a message, hey, the iPhone 20 is out, go get it. you know you know you're a sucker for buying new technology, so let's give us your money, that type of thing. So yeah, that is a thing that they do, right? um okay, another example, Amazon's quick delivery, right, says emphasis on customer service and earn them millions of customers. And here's where I get like sharply critical of them, right? Because I used to be an Amazon vendor, right? And so a lot of people don't know this about Amazon, but Amazon does have these big warehouses and they distribute product. And sometimes Amazon is the direct retailer. So in other words, they go to the manufacturer, buy the product, put it in their warehouse, and ship it to you when you order it. But most of the products on Amazon, and I don't know what the percentage is, it's huge, like 90% plus, I would guess, are really third party sellers using Amazon as an e commerce platform. So when you order through them, Amazon sends the order to somebody else, and that gets fulfilled through somebody else. Sometimes that somebody else stores their product in the Amazon warehouse. That's kind of interesting too. Now, I used to be one of those sellers, so I have that insight as to how it all operates. And I will tell you, by the way, that their terms for third-party sellers are horrible, right? You can sell a lot of product through Amazon, and I had for a little stint a few years back in the 2000s where I was doing like a few hundred orders a day with my business through Amazon. Wonderful. Then I started calculating it, right? Because I'm a data nerd, right? So I started calculating what's my profit on this. And it turned out I was making like 2 cents on the dollar, something like that, really tiny. Meanwhile, Amazon's taking 20% off the top. I just want to let you guys know that up front. That's your standard vendor rate, and they take it off of shipping too. This is really weird. So, anyhow, Amazon is really weird in how they operate. I don't necessarily think they're always the best choice, and I usually try to not buy from them. This is just, I'm just telling you guys this up front, just in case you think I'm opinionated, I totally am. However, it's hard to deny the fact that they have everything. Their prices are good, and you can get it almost instantly, right? Especially where we live in the Chicago area. They have so many warehouses. They have a warehouse up in Oak Creek here now too. So if I order something, and this has happened before to me, I order something in the morning and it's here by like noon. And I'm like, what? this is great. This is wonderful, right? All right. So they do a lot of recommended stuff on their pages. Whenever you look at a product page, you'll say people who bought this also bought this, or people who like this also like that. That's a really big thing, right? And the thinking is that you're going to find something better, or you're going to find something additional. You're going to spend more money, basically. And the more money you spend, of course, the more money they make. But the point that they're making here is, hey, I came on here to buy dog waste bags, but I ended up also buying, a hard drive. They can put it in the same box and save the shipping, right? Or one delivery instead of two, right? So that's more cost effective for them, which is one of the other reasons they do it, right? All right. So some of the potential benefits, it says improved engagement and delight. Well, I don't know if I describe buying dog waste bags as delightful, but I guess for some, perhaps, and it says here, sometimes seeing a return on investment doesn't involve explicitly asking for a payment, right? They just, it says simply encourage engagement and activity on your product platform. So they're keeping you on their website. And if they keep you on their website, you're not shopping somebody else's website, right? So if I walk into Walmart and everything's on sale, I'm very unlikely to cross the street and go to Target because they've got everything at Walmart. They have everything I need. It's that mentality. Um, all right. So they asked the grand question: why do we need these systems? But let's just kind of go through here, and they're looking at some online companies, YouTube and Facebook here. It says YouTube has subscription options. Can I ask, is anybody here a YouTube, like pay for YouTube?
I do, yeah.
So Chris, you do?
Yep. I mean, I didn't for a long time. I watch a ton of YouTube, honestly, kind of like an embarrassing amount. But going back to, I like had paid to go ad free and then went back to going on to free ad version, and it's like unusable. There's the ads on
Yeah.
YouTube, I feel like, especially in the last like year, 18 months, I've gone crazy. So it's definitely worth it for me.
Yeah. And you know what? I've kind of bopped back and forth between subscribing and not. And um, I will tell you, like the Brave browser is my friend because it does strip some of that stuff out, but I know what you're talking about. It's kind of like when you watch Netflix and then you go back to regular television, you go, oh my God, how do people watch this? It's like every 3 minutes I have to like step away for 5 minutes. But yeah, okay. So um, but mostly the revenue comes from advertisements, right? That's the point here. So if you keep going back to the website, they're going to make more money. That's the thinking. It says YouTube doesn't optimize for short-term view length, which might encourage pushy or flashy tactics that wouldn't genuinely delight users. So in other words, I think and I think maybe this has changed, right? Because now, what do they call them on YouTube? Reels, right? No, that's Facebook. No, they call them YouTube Shorts. I think is what they call them. But a lot of that stuff is kind of like such, I know people are into it. I get it. Um, such so lacking in content. It's like lots of like banners and kind of flashy presentation, but it's really short lived and really pretty empty of content. And it says the service aims to encourage long-term use because advertising views is the return on investment that serve YouTube. So like those advertisements do make money, right? Now, you guys know I already post my videos out there to YouTube, and I used to do it through school, and I got a bunch of subscribers, and I'm like, oh, if I did this on my own channel, I might make some money off of it, right? Because you can share in the revenue if people are watching your video to absorb their advertising. And so, yeah, I'm trying to work that angle, right? I'm always looking for that passive income, right? Facebook does kind of the same thing, right? And they, I don't know like where they tap into their data, but they have a lot of stuff they throw up on your feed that is related to stuff that you've been searching for, looking at on other websites, or if you're always looking at videos of, I don't know, cute cats, they're gonna show you more videos of cute cats. Or if you're looking up, whatever, you know, um, they're gonna show you information about that, right? So that's kind of some of the point here. All right, so now we'll start talking about some real world applications of this. And it says Amazon uses as a targeted marketing tool throughout its website. Absolutely. And if you've shopped them, you know this. And actually, it's part of why you like going to the site, real frankly. You know, so when a customer clicks on your recommendations, it takes you to a page where it says recommendations may be filtered further by subject area, product types, and ratings, right? So in other words, if I'm looking at a book and then it will say, oh, you like to read books about history. So here's some cool history books, right? But it might only give you history books about war because you're always reading war history, that kind of thing. But also if you're rating stuff. So if you go to the trouble of rating, and this is a problem that Amazon has had in the past, where some of the ratings on some of the products were false, or the people that posted the product would create phony ones. So then people would rate plugins to filter those out, and that's still a problem. They've kind of cracked down on it a bit, but not much, by the way. The other problem like YouTube would have, and this is, and they've stopped this now. But in the old days, people would write software on, and post a machine on the internet, and then they would just have it go to your video over and over again. So the hits would go up and they would get more advertising revenue. And then they figured out, oh, this is phony. It's coming from robots. It's not coming from humans. Right. The other thing that is kind of interesting, I do like to read reviews when I think they're from real people, because I think some of the insights there are a lot more helpful than what a company says about their product, right? But they also, Amazon does, we're recommending this because of your interest in this product. They tell you that up front, so I think that's kind of interesting. All right, I am going to play this video, and it says here that according to a paper by Netflix executives, right, the video streaming services AI recommendation system saves the company, in their calculations, about $1 billion actually annually. That's a lot of money to save. And if that's ending up in like a CEO's pocket or the shareholders' pocket, I guess they use personalized or recommendation systems, personalized diversity to generate top 10 recommendations for user households, so it can offer videos that each member of the household may be interested in. So if you guys do like we do, where we have every person in the family has their own profile, and then like the kids will watch something, what they watch will pop up on my feed as a recommendation, so that way we can talk about it, right? That's one of the recommendation things. Let's watch this video real quick and see what this guy has to say.
Work very well. About 70% of everything Netflix members watch is a personalized recommendation. Recommendations start immediately when you join Netflix. Initially, recommendations are personalized based on your answers to a simple taste survey. If you told us you love comedies and horror, we might recommend scary comedies, but this is only the starting point. Our recommendations get fine-tuned as you use Netflix. That's how we get to know you better. Our personalization technology is based on a set of techniques that are always learning more about the movies and TV shows you like to watch. In addition to analyzing what you watch, we also look at what others watch to come up with the best recommendations for you. Our recommendation engine even creates highly specific genres for you. Personalized genres are generated using thousands of movie and TV show characteristics, including actors, storylines, characters, and time periods. We also give you personalized top 10 recommendations to make it even simpler to find something great to watch. There are also rows of recommendations based on specific shows you've watched. If you haven't noticed Netflix personalization in action, compare your Netflix to a friend's, and you'll see how unique your tastes actually are.
And that is really true, because this is a goofy thing I do, is I'll look at my profile on Netflix, and then I'll look at my wife's, and then I'll look at my son's, and I'll look at my daughter's, and go, huh, why such weird diversity? But there is that always, like, if they're watching something, they try to suggest it to us. I think it's really interesting that, because the screens that they're showing on this video look like they're about 10 years old. Like, that's back when they were still using stars to rate stuff, which I think is a better system personally, but they went away from that because they felt it was too particular, right? And then I don't know if you guys remember this, but they used to have on Netflix reviews, like you could read people's comments on stuff, and both of those things went away. Now it's just thumbs up or thumbs down. And what I discovered is I don't like to click thumbs up, because then it really skews what comes up in my feed more than I want it to. But that's a personal thing. The other thing that I've noticed on their platform is, oh my God, it's like, I know this thing is on here, and it will never come up on my feed. And I have to go searching and hunting for stuff, right? And then I discovered that if you go to Kaggle, right, and we'll talk about that later, Kaggle actually has a fairly updated list of everything that's on Netflix, right? And then you can look at that list instead of going to Netflix. They got this on there, and you go and search it, and oh yeah, there it is, right? And some of it also is only available in other countries, but whatever. All right, so that's the one thing. Best Buy also uses recommendation systems, and it says since 2015, They've used information in an attempt to predict what customers are interested in. And it says the query-based and item-to-item system creates cluster models that allow the company to make customer recommendations. Now, real frankly, I used to hit Best Buy both in person and on their website a lot in the old days. And now it's like if I walk into Best Buy, it's like, oh my God, it's somebody's birthday, or oh my God, it's Christmas and I forgot to get something. Or I'm thinking about buying a big ticket item online and I go into Best Buy, and what do I use Best Buy for? To see the product in person before I buy it online, right? Who owns Best Buy now? Well, just if you guys aren't sure, somebody ask your Chat GPT or your Google, who owns Best Buy now? Nobody. All right, I'm going to ask my phone if you guys don't ask. Hey, Google.
It's in chat.
Vanguard? You guys need to go further down the rabbit hole.
I just asked ChatGPT. I'm surprised. I said BlackRock as a joke, but ChatGPT just told me their first two were BlackRock and Vanguard.
Okay.
Maybe that has to just be like top investors or something.
That might be the case. My understanding is that they were swallowed up by Amazon, that they're an offshoot of Amazon now. Yeah, yeah, they have a large, yeah, you know what? That's really kind of a good way to look at it. So, yeah, I mean, who really owns them? But I think that's what happened to them, right? And why they maybe don't have as many stores, or they don't have as much stuff in their stores as they used to. But kind of interesting, anyhow. All right. Another real world application, and I think this video is kind of old too, but irrelevant. Um, it says they use recommendation systems so users can really find videos that are relevant to their interests. So, like if you're watching my machine learning videos, the day after or whatever, if you miss class, chances are in the sidebar of the video that you're watching, they're recommending other videos with similar content, and then pepper in a couple ones from other stuff that you've looked at, right? And sometimes that's really cool, right? It's like, oh, I was looking at this, but hey, this is here. Right. And I do kind of like that on YouTube, and I think they're really good at that. YouTube also is a social media platform, and a lot of people forget that it's not just a video delivery system. It also has likes, dislikes. You can there's threaded conversations, there's live chats when things are out there. And real frankly, the social interactions on there are a lot more like wild west than like something on like Facebook or something, because on Facebook, if you make somebody angry, they can report you and they can cancel your account or delete your account temporarily or whatever. On YouTube, it's like a free-for-all. People have weird screen names. This is horrible, this is great, whatever. So I think that's an interesting thing. But let's take a look at this video really quick here.
From YouTube can really help you out. I'm Rebecca, and today I'll show you how YouTube picks videos for you and what you can do to influence them. So how does YouTube know what you want to watch? Recommendations are based on videos, genres, topics, and creators you've previously watched. So let's say you're really into cat videos. When you watch one, YouTube may suggest other cat videos or more animal videos in general. This basically applies to anything you watch on YouTube. No matter what you're interested in, YouTube can find videos that fit your interests. As you continue to watch more, YouTube will offer better recommendations for you. If you're watching videos while you're signed out, you'll see that suggestions are first based on the popularity of videos in your country. But once you start watching more, you'll start to see more personalized suggestions. That's why it's best to sign in. Since your recommendations are linked to your account, you'll be able to see them wherever you are. If you're signed in and you see recommendations that aren't what you expect, there are a few reasons this could be happening. First, if you share an account or device with someone else, the videos they watch will influence your recommendations. Second, the categories of videos can be a little broad. For example, if you watch a funny video that's labeled as comedy, you may see other videos that are also labeled as comedy. Since everyone's definition of comedy can be a little bit different, you may see comedy videos that just aren't funny. If this happens to you, we've got good news. You can actually remove videos, channels, and sections that you aren't interested in to improve your recommendations. Okay, let's sign into my account to give you an example. I've watched a channel featuring different pets, and I'm seeing a few dog videos come up. Since I'm more of a cat person, I could choose not interested to remove videos that have dogs in them. If I remove 2 or more videos from the same channel, that channel will no longer be recommended to me. But what happens if I see a recommended channel of just dogs? I can also choose to remove the entire channel. If you've accidentally removed a recommendation that you want to keep, you can click Undo to restore it. Currently, you can only do this on a computer. If you've made too many removals or if your interests have changed, you can clear removal history at history.google.com. Click this.
Okay, and I'm actually gonna kind of cap it there. I think you guys get the point of this. Once again, this is a little bit antiquated, but it does help, right? Like if you really like a channel, like I've been watching a couple of like AI podcaster guys, and I really like the stuff they put out there, and I watch a couple of like music things that I really like it. So I subscribe, so when they put out new content, I can see it pretty easily. But I think it's really kind of interesting how their algorithm works.
This icon in the corner.
And sorry about that. But it does work, I think, maybe a little bit better than, for example, Netflix recommendation system. And this is an opinion, mind you, right? So you might feel very different, but we are looking at like Netflix, but that's not like the only streaming service. That's just the one that we're using as an example, right? Like a paid subscription streaming service. All right, so here, recommendation system, and I don't know why the guy called it a recommender system. I don't know if that's a typo. So, maybe overseas they call it recommender. I don't know. Basically, it's an information filtering system that seeks to predict the rating or preference a user would give an item. So it would be kind of safe to assume that if you like one thing, you might like something else that's similar. I mean, that's just very logical. All right. The point of it is to suggest relative or relevant items. And it says, imagine you're on a website that has thousands of products. Clearly, you don't have time to go through each product to find what you're looking for. To improve the experience and help you find your product, the recommender system will suggest products that match your preferences. So like if I'm always shopping for guitar parts on Amazon, it's going to show me a lot of guitar parts, right? All right, so now we're going to start getting into like how this like functionally all works, by the way. And they use basically 2 different kinds of information at the point of this slide. One is characteristics, and this is basically the actual information about the things you're looking at, and let's just use the example of maybe products. I think, so for example, like if I'm always looking up guitar, or you're always looking up, fast cars, or what category are you looking at? Right. So, hey, if you're interested in guitars, hey, there's a whole bunch of guitar stuff. Right. But also they look at the user item interactions. Right. So in other words, the things that you can interact with, like how many times did you buy that? Or did you like that product or dislike that product? Or what kind of rating did you give it? Right. And they look at those things. So if you rated, let's say I buy an O'Reilly book and I really like it and give it 5 stars. Well, they're going to show me lots of O'Reilly books. All right. He like latches onto this example here of talking about the Avengers, and I make this naive assumption, right, that in pop culture, most of the people that are younger than me know who the Avengers are, knows that it's like a Marvel movie series and all that stuff. And there's some of you that may be completely unaware, but it's basically that. I think it's really fascinating. I don't know if you guys pick up on this kind of stuff, that Here he spells factorization with an S, and there they spell it with a Z, like, so British, American, right? The correct British way, the Queen's English, the American English. All right. All right. So they're going to use this example here to kind of explain how recommendation systems work. And what we see is a matrix, right? And on the left-hand side of the matrix, we have, okay, and they're saying here, the following actors, we're imagining they're users of a recommender system. I don't know if that's really the case, but we have these 5 actors. Most of us are, familiar with their faces or their names. And then at the top, we have a list of movies seen and rated on a 5-point scale by the same user. So these actors watch these movies and then rank the movies on a scale of 1 to 5. 1 to 5 stars. And you may recognize some of the movies or not, but if Avengers, Infinity War, et cetera, et cetera, et cetera. And then they refer to each of the columns by these pseudonyms of like new 1 through 5 and I1 through 5, but they form a matrix, right? Because each user rated each movie, right, and gave it a value. So there's a numeric value, and this matrix is kind of in the form of a heat map. So like the worse the score, the more red it is, and the better the score, the more blue it is, I guess, right? That's just their color coding. Right. Right. It says from the rating matrix, it's easy to observe that some of the users have similar tastes. So, for example, they're pointing out that user 2 and user 4 seem to like the same thing. So, it's like they differ on this one, but they like, one guy likes Deadpool and the other guy doesn't, basically, is what that is. Or is that Spider-Man? Spider-Man, right? So they differ on that one, but basically their concepts are the same. They also notice that user 1 and user 5 have similar tastes. So the point is, user 3 is unique because he's awesome. Okay, whatever. So what they're looking for is if this person likes this movie and this person's never seen that movie, but otherwise has very similar tastes, so there's a good chance this user might also like that movie. See how that works? So it's not based on what they watched or what they liked or disliked or what rating they gave it, but compared to others that have similar tastes, they're making a suggestion, right? Okay, so little joke thrown in, whatever. All right, so let's do some assumptions here. It says, assume that user 4 did not watch. So user 4 did not watch I5. And we want to know if they'll like it or not, right? We need to find a user with similar preferences, and then taking the rating given by I5, and assume that it to be the rating of user 4 for that item. Okay, so in other words, if they're pretty similar here, we can probably assume they're going to be similar here. You can see user 5 didn't really like it as much, that much either, but user 4 really did not like it at all. Right. So, all right. So this user rating obtained from the user dependency, we tell if user 4 will like I5 or not. So that's, I think, pretty assumptive, actually. All right. The goal really is to find all the correlations when you have data sets like this, to see where the correlations are, and you put it in a matrix, and then we will factor the matrix, multiply and factor it, and figure out what to do with it in essence. Okay. So I think what we'll do is I'll do this slide and then we're going to take a break. I think it's a really good pause point here, but I'm going to leave you with this thought, and we'll come back about this thought. And when we are looking, and this is just a mathematical tie-in, when we take a number and we factor it, what are we really doing? We're breaking it down into its component pieces. And when you factor a number, what you're doing is you're trying to find the things that you multiply together that most efficiently make up that number. Now, if the number 55 is divisible by both 5 and 11. Okay, so those are the factors of that number, right? And it says basically what factorization is a method of taking something big and showing it as a product of smaller factors. So breaking it down into smaller pieces. All right, let's take a 5-minute break. And I'll see you guys back here at about 8:57 or 8:58. And I will pause and mute. And so I'll see you in a little bit. All right, we're back from break, and hopefully you guys thought about this factoring thing just a little bit, but it's something we learn in math, right? You try to factor a number into its simplest forms and what steps of multiplication you can take to get to that number. And like a lot of numbers we assume can be factored by a lot of different things, but in many cases it's not really true. We have things like prime numbers and whatever that come into the mix. That can only be factored by themselves or one, that type of thing. All right. When we start to do math with matrices, right, where we're taking a matrix or a table of numbers and doing it against another table of numbers, we can also take the numbers in a matrix and factor them as well. So this is a really kind of interesting mathematical concept. Not a new one, by the way. This has been around for a while. But it says this takes rectangular matrices with smaller dimensions representing a big rating matrix. So the whole concept, the general layout that we had in the previous slides was the movies or the items were on top and the users were on the thing. But I want you to notice that the users are a matrix also, and the items are a matrix. Even though they're one dimension, it's still a matrix, right? And then we have the rating matrix, which had rows and columns, but all of them are rectangular in shape and have items within them, right? Now, the stuff that goes inside each one of these, right, these factors, as they say, retain the dependencies and the properties of the rating matrix. It says one matrix can be seen as the user, one can be seen as the item, right? And it says, notice, with the user matrix where the rows represent users and the columns K are latent factors. So in other words, these are the only users that are relevant. All the other columns that we were looking at, I mean, they're from that user, but they're not really part of it, right? That's the point. And the same thing with the movies, right? So those are the movies, and whatever ratings we give them, it's all dependent on who's watching it, right? So it's not really, basically part of the data. And that's why we call them latent factors. They're not, they're related, but they're not really it, So and it says here, and I want you to notice that the K number, right? The K represents the latent factors. And then the item matrix, there's no stuff going down. Those are the ratings, just the stuff up there that count. So just the movies, just the users. Other stuff is relevant, but it's not part of it. So the latent factors, it says, are otherwise called features, right? And you think about like how we've been talking about data and dimensions and features, right? And they're characteristics of an item, right? So in our case, features of the movies could be its genre, the actors, the plot, whether it's a Marvel movie or not, or it's DC Comics or whatever. The latent features of the user could be their age, location, sex, superpower, right? Because these are all superheroes in the movies, right? But those features really aren't demonstrated here, but they're still part of those individuals. And the movie type and ratings and actors and stuff is part of the movies, but we're not looking at those features. Those are latent features, right? It says the features chosen by matrix factorization is irrelevant to the solution. And I think that's kind of an interesting thought. And it says that the matrix is represented as a dot product of the user and item matrix. So like what happens here is a byproduct of the inputs from there. All right, so they're going to kind of give us a basic example. So please follow with me here if you can. So they're taking, for example, they're saying that this guy, I forget his name, whatever, obviously this is the PowerPoint author's favorite guy out of all of them. He's got features that we're not seeing, right? And in this case, it might be the ratings, right? So he's rating some stuff. So we call that a feature and a feature. Also with the movies, right? We have ratings that they received from others. We don't know who that is, but these are ratings or whatever that relative to their features, and maybe these features are indicative of something else altogether, but we're not necessarily seeing that. However, when we take these features and we do multiplication on them, so I'm multiplying basically 3 times 1, right? 2 times 0. And then here I'm 3 times 1 and 2 times 1. See how that goes? And then we come up with these to get these as an output. Okay, so and read the last bullet. We assume our factored matrices have only 2 features, F1 and F2. Having Ryan Reynolds in mind, we assume F1 to be if it is a movie with Marvel characters, and F2 to be if Ryan is in the movie. Right, that they're just making extrapolations here, but they're showing you how the math works. That you can multiply matrices even if they aren't exactly the same size. You can still do math on these, right? Okay, according to Ryan, if it's a Marvel movie, he'll give it 3 points. If he's in the movie, he'll give it 2 more, right? So he must be in this movie, right? All right, typical Ryan. Okay. The item matrix contains binary values, right? So think about this, where value is 1 if conditions mentioned above are satisfied and 0 otherwise. So this is actually a true false matrix for the item, where this is an actual rating. Okay. So by performing a dot product of the user matrix and item matrix, so we're taking those 2 separate things, Infinity War gets 3 and Deadpool gets a 5. And that's without them knowing how you would actually rank it. You see, that's the whole point. So it's extrapolated. Okay, so here's a bigger question, and I think this is very pertinent. How do we find the right factorization? Like, how do we determine that? Okay. Well, basically, we do it with machine learning, which is why it's part of this class, and why companies like this use those kind of algorithms to do this kind of work. The model learns to find latent factors to factorize the rating matrix. And it does that by training, right? And remember, we're doing unsupervised training, so we're working with, in some cases, unlabeled information. And then we arrive at, it says, the best approximation through the root mean squared error, and to minimize that value. So in other words, the differential between the values that are calculated is minimized to its lowest possibility. After they do that, that factorization, the squared error is calculated for every movie rating in the matrix, and the root value of the mean of squared error values are minimized. Okay? And that's what this equation is. So they're looking for the differences and trying to make them as small as possible, right? And this will be a process. So like when you first would be on Netflix, and let's say you have a brand new user account and you've never been on there, what are they going to present to you? And so from a consumer standpoint, I kind of wish that's what they would present to me every time. I'll just put it out there, right? I don't always like to be recommended. I want to kind of explore and find weird stuff, okay. But the more you watch it and the more you interact with the system. So I keep watching, I don't know, stand-up comics, and I keep watching action movies, chances are I'm going to see a lot of that in my feeds, right? Where otherwise, but it's a learning process. They don't know until you've done it. And I think that's fascinating. All right, let's take a look at it mathematically. And yes, take a breath. This isn't on the test, basically. But what they're doing is they're taking that big grand matrix that we have, right, the X, they're breaking it down into its subcategories. So we have a matrix for item, user, and the ratings are all represented here. And some of these, and I'm trying to really kind of explain their terminology in the graphic a little bit, but you have like basically you know, the row and column index, and it can expand to whatever level, and it keeps going. And this is multiplying all the different factors against each other. But that's achieved by the smaller matrices and their features, whether latent or not, combined together to get what we call the singular value decomposition. So it says, you know, this is, they call this the simple and most extensively used type of matrix factorization. And this is used because it is pretty mathematically efficient, right? Because we're basing it on very simple factoring, mathematical factoring. And, you know, when we look at the result, we have a single value that we're looking at, but there was a lot of stuff that went into it to get there. Like 55 is the byproduct of 5 and 11, right? So that's kind of the point here. All right, so it says here, the intuition of SVD, it says, let there be matrix X, the one on the left, with the dimensionality of M and N, right? I hate like the way they do math stuff. It makes it sound so formal, but that's how they do it. This matrix can be viewed as a dot product between 2 or 3 matrices, with each matrix having dimensions of M and R and N. And then you notice the one that's R and R, right, which is a diagonal version of the same thing, basically. Right, so we're going to break down the concept here into terms, right? So U is the left singular vectors, right? The column on the left. V is the right singular vectors, and then we have singular values, which are calculated, basically. That can be also referred to as S, you know, so singular or, you know, whatever. And then it says, notice the shapes of each of the matrices. We see that S is a diagonal matrix. U and then V, which they call V transpose, are rectangular matrices with their respective shapes. So they might be the same shapes. It could be very different shapes or somewhat compatible, but maybe not. We don't really know that, right? It depends on the data. All right, so the 3 matrices that we're working with are the ones on the right side of the equal sign, the singular of U and then VT, and then we have the singular value matrix here. All right, it says notice the shapes, right? We see that S is diagonal, U and V transpose are rectangular, right, with their shape. Okay, so using the same words over and over again. And I find this like, you know, I don't think it's maybe as clear from the way I'm explaining it as like if you were taking a math class and you had to do mathematical proofs on this, and you did a deep dive on it, right? You would totally get the math of this. But this is not the kind of math that you learn probably at Gateway. You know, we're introducing you to conceptually how it works, but we're going to let Python do the magic in the background. All right, and they go through the naming of everything. Rows in the U matrix often called left singular. V matrix are called the right singular. And then it says you can think of these 3 matrices as factors of X. So these are the pieces that we multiply together to get the pieces in the big matrix, right? So if you multiply all these matrices, you get X as expected. But if we decomposed X, we would break it down into these 3 factors, right? Like we might do with a regular number. It says one downside of SVD is the fact that when the original matrix is sparse, or in other words, doesn't have all the data, the left and right vectors can be undefined. So that's problematic. So it's kind of like logging into Netflix that first time and they don't have any data on you. They don't know what you like, you know? And I don't know if you guys recall this process, but it's been so long ago that I did it, but I remember the first time I signed into Netflix online, if I'm not mistaken, they had like a question, what kind of movies do you like? Right? Like action, adventure, comedy, you know, whatever. And you click a bunch of boxes. And of course I'm like, I like them all. So what did I do? I clicked everything, right? Or you can do the opposite and click nothing. And you do it later. All right. And I did some sort of a sign in even earlier today where I got asked a question. I forget what it was. That was very similar to that. Yeah, pretty weird. All right. So what does this matrix look like? well, sort of like this. So in other words, here we have the user matrix, right? Here we have the item matrix. These are multiplied together, and even though their angular shapes are pointed in different directions, we multiply, and as we multiply, we come up with this grid. Notice some spots are empty, right? Because we don't have, like, for example, if I had two more rows here and two more columns here and two more rows here, I could multiply it all together. But as it sits right now, I can only multiply this against the spots where there are data, or the data is, and I don't know if that's really valid math there or not. All right. Now we kind of like do this stuff with code, right? And this is kind of where we're pushing ourselves to tonight. And once again, we're using scikit-learn, right? So this is a library that's built into that. And as you guys are picking up, this is a really important library for doing this kind of analysis. And it's one that's used by a lot of different areas and fields, by the way. But basically, what we do to get a single value decomposition here is we run from here the decomposition truncated SVD. And this is kind of a way of saying that, like, we're sort of factoring it, or we're decomposing the values. They indicate here a bunch of different parameters and attributes. They say we have 5 tunable parameters and 3 attributes that go with this. And you can see, the tunable parameters on the screen there. Oops. All right. And I think, does this slide repeat? That's weird. I thought I saw the slide twice. Okay. All right. So now, okay. So now, yeah, I guess it does repeat. So now they're going to look at the different, there's somewhere here, there's a repeating slide, and I found it earlier, and I think that maybe it's a mistake, and I'm not really sure. Here it says we look at one of the important parameters is the number of components, or n components. And it says it's the desired dimensionality of output data. And it says it must be strictly less than the number of features. Okay. So, in other words, if we have a lot of features, whatever we select for that number must absolutely be less than that. By default, it's set to 2. And they say it's for easy visualization. And you know what? This kind of ties back to that thing I heard at the conference today, to make make it simple, that simpler models sometimes actually work more effectively, which I think is kind of fascinating. All right. Now, you guys tell me, are these 2 slides identical? The image certainly is. The words aren't. No, the words are identical too. Okay. Omit slide number. This slide got duplicated somehow. Right? And I don't know if it was by me. And I'm looking at all the stuff on it. It's just a different size box. All right. Once again, we'll look at an example of code here. And they show you an example implementation. Notice that they have numbers in there for n components, and here they're choosing 5. Why 5? Okay, well, if we're looking at the movies, right, how many movies did we have up on the screen? How many features are part of that movie? Well, we don't really know that, right, necessarily from the data set, but you can employ this pretty easily. And here's some, example code, right? And this is not like the code that we have in our sample. It says we're implementing the entire SVD algorithm with just one line of code, right? And notice that they have some other values that they type in, and we'll look at these. And of course, we have the magic number of 42 in there, which is the answer to the universe, apparently. That's a random state seed number, by the way. And, only people who read that book get that, right? And there's a thing about a towel in there, too. You got to bring a towel with you wherever you go. It's not bad advice, by the way. Right. All right. Let's move forward here and take a look at some types of recommendation systems. So, okay, we're looking at factorization and SVD and what those mean, sort of, and we kind of sort of get the picture of it. But there are 2 different types of recommendation systems. One is content-based filtering, right? Okay, so let's look at the definition on this. This is based on the description or some data provided for that product. It finds a similarity between products based on its content or context or description, right? The user's previous history is taken into account to find similar products the user may like. For example, if a user likes movies such as Mission Impossible, we can recommend him the movies of Tom Cruise or movies with the genre of action, right? That makes sense, right? So content based. So we're looking at the content of what we're recommending to drive the recommendation. Oh, you watch a lot of Tom Cruise stuff. Oh, you watch a lot of stuff that has stuff blow up in it. We'll show you movies like that, right? Makes a whole lot of sense. Hey, Mission Impossible 1, how about Mission Impossible 2 or 3 or 4 or 5 or 6 or 7? Right? There's a whole bunch of those now. And yes, I've seen every single one. Right. Right. So that, once again, that's the definition. So what does it look like? It says in this scenario, two types of data are used. First, the likes of the user's interest, user's personal information, such as or sometimes the history. So for example, they would take like George, Martin, and I, right, and put us into one category because of our age. It's like, oh, those old guys, right? And then they'll take a look at the younger people here in the session and go, oh, it's those young people. Yeah. They'll like very different things, and they're probably right. They're probably right about that. Not always, right? So this data is represented by the user vector. Right? Remember that terminology of vector. So information related to the products known as a item vector. So we can have a user vector. So if when it's related to the user, it's a user vector. When it's related to the item, it's an item vector. And remember, vectors are numerical representations of things. The item vector contains the features of all items based on which similarity between them can be calculated. So when we're doing that cross-checking, if we're doing it based on content, are we looking at both? An interesting thought. Okay. All right. Here's some advantages. The user gets recommended the types of items they love, right? They're satisfied, hopefully, by the type of recommendation. I find they sometimes fail, but hey, whatever. And then new items can be recommended. Just data for that item is required. So, for example, if Tom Cruise comes out with another movie and it happens to be action adventure, chances are they're going to recommend it to me because, hey, you watched all the Mission Impossibles or you watched all the Fast and the Furious. So you're probably like Hobbs and Shaw, right? I mean, it makes a whole lot of sense. Disadvantages, though. All right. If that's all you watch and that's all they push on you and you just keep watching it, you're not going to show you anything different. You're never going to get a rom-com and you're probably not going to get a reality show, right? Or you're not going to get a slow-moving drama, Businesses cannot be expanded as business cannot be expanded as the user does not try a different type of product. So like there are some disadvantages to this because you know what, sometimes when I do a deep dive in search, I find that other thing that I never thought I would have liked, but I really like a lot, right? So that's one thing that's a problem with this. So if the user matrix or item matrix is changed, there's what they call the cosine similarity matrix needs to be calculated. And you know what, they have a link here, I think, to Wikipedia, and I'm not sure if it opened or not. Let's see. Well, let me find my browser here. Not that browser, this browser. All right, let's see if we can just copy the URL. It is just not taking me there. All right, anyhow, I can see it. It says, okay, just look that up on Wikipedia, basically. All right, is what it's telling us to do. So let's just do that really quick, just to satisfy that. And all right, This is, pretty heady kind of stuff. So it's a metric used to determine the similarity between two non-zero vectors, right? So there's data by measuring the cosine of the angle between them in a multidimensional space. Yeah, that's like pretty deep stuff. So cosine and sine are continuous waveforms, and if you study like trig and calculus and stuff, you learn about that. If you plot them on a chart, they go positive and negative, and they like on a like a wave, up and down, and they can calculate basically the similarity based upon where the cosine drops in, and of course they go into dot product. Sounds familiar, right? The magnitude of the vectors and the divide, and they show you the formula, and yeah, we're headed there. So all right, that's content based filtering. However, there's also collaborative based filtering. All right, so let's talk about that. So the recommendations are made based on the user's behavior. The history of the user plays an important role. Okay, so for example, if the user A likes Coldplay, Linkin Park, and Britney Spears, which I find unlikely, but maybe, while user B likes Coldplay, Linkin Park, and Taylor Swift, right? So you see they got two in common, but one uncommon. There's probably a good possibility that the other person would like Taylor Swift and the other person would like Britney Spears. Okay, makes sense. Or how about like that sort of recommendation on a website? Customers who bought this item also bought, you know what I mean? So like you get like I don't know, a Ninja blender, and then they also bought this smoothie mix to go with it, that kind of thing. So that's not uncommon either. Right. All right. So it says user collaborative filtering here. And it says it first finds the most similar users with respect to our given query user, and then predicts the item preference based on the top similar customer ratings. So it says, for example, if we want to predict how customer C would be giving a rating to movie M1, then we'll take a weighted sum of ratings by users similar to that user. So in other words, it says users who are similar to you also liked. And I do see that terminology on websites are similar, right? So in other words, but this is once again based on a rating. So for example, if I buy a certain brand of pizza and I give it a high rating, and other people have high ratings of other products I'm similar with, they can predict with a high degree, not certainty, but probability that you might also like that. All right. It says, it is similar to user similarity. The only difference is, and this is, we're talking about item to item collaborative filtering. Here, the similarity computation is centered around the item instead of the user. And this is really kind of a different flip, right? So like if you like a bunch of products and somebody else likes a lot of similar products, but you have some that you don't like in common, chances are they can run those things that you haven't tried, that you haven't rated. You probably like them, and they're probably right. Here, when we're looking at the item, right, it's focused on the item instead of the user. So let's say we want to predict movies to a user, then we first find the highest rated movie by the user and find similarities to this movie with respect to all other movies and suggest top K movies. The users who like this item also liked. So in other words, now they're not looking at your rating, they're looking at what you liked. See the difference, right? Yeah, so this you like, that you didn't, not the rating necessarily, right? All right, so what are some advantages of this? So basically, new products can be introduced to the user and the business can be expanded and popularize new products. Okay, that makes sense, right? That's what they want. But the user's previous history is required, or data for products is required based on the type of collaborative method used. So in other words, if I don't have data to start with, that's like being a brand new Netflix user. They have no data to work with. However, as we're about to discover in our code exercise, that there are platforms that gather data about movies, right? like genre, actors, storylines, ratings, um, category, whatever, right? And they have data based on, I don't know, critics, other users, right? So when you come in cold, they're going to try to recommend to you stuff they think you like based on other data, right? But it is data is required to have a starting point, right? So when I go into Netflix, they'll have a category that says like, award-winning movies or, Golden Globe nominees or, whatever, right? And it's not, it has nothing to do with you. They're just telling you other people who know movies thought these were great. You've never rated any of this stuff, so here's some stuff that might be good, right? Also, and this is a Netflix thing. If you're one of those people that's like you start watching a show, it's got a bunch of episodes, and you're just, Trailer Park Boys, I love it, and you just episode after episode, right? And they know you're a binger, right? And they'll recommend stuff that's really bingeable that flows like that, right? Not everybody watches TV like that, but and that's a great show, I think. By the way, if you've never seen it, see it. All right. Disadvantages: the user's previous history is required. Okay, so we just talked about that. The new item cannot be recommended if no user has purchased it or rated. So, like, if something like a movie just comes out and nobody rates it, how do you know if you want to see it? And so this really kind of explains like why with movies or TV shows they pre-release them to critics to watch and review them before the public gets to see them. So if they think it's awesome, now they have data saying, hey, it's awesome. Look, this critic thought it was awesome. Siskel and Ebert, that kind of thing. Right. Before it ever hits the movie theater. All right. Folks, we're reaching the end of the lecture here. So these are the key takeaways. A lot about recommendation systems, but it's really kind of like the math underneath. Once again, we're going to let Python do that math for us. All right, I'm going to pause the video here for a moment. All right, since we're kind of at the wrap-up point lecture-wise, it's now time to focus on a couple of different things here. So the one is I do have a dependencies file here that has a bunch of stuff for you to work, and here's the data files. So one thing you'll notice, there's a Python notebook that's a starter for you, right? That gets you most of the way to getting your homework done. And then we have these different files here, and you'll notice that there's a ratings file. I want you to notice this one's a really large file. All right, so this is the one, if you're going to use these data points, this is the file you should use. Otherwise, you should get updated data. In the example Python notebook, they used the small version. So they took the data set, trimmed it way down to make it manageable. It's only a little over 2 kilobytes or 2000 kilobytes, excuse me, as opposed to, 692 is pretty huge. So I just want you to be aware that there's different data sets here. And what I would recommend is that, like, for all of these, right? So I'm just going to do an example. Like, I'm going to look up like movies metadata here, and my Excel is opening. We'll see if Excel even opens it. And I know some of us have been having this issue. This is a CSV file, and I'm opening it in Excel. And I just want to show you what's in these files. And you guys should be doing this stuff, right? And I shouldn't need to coach you on it at this point. Whenever you have a data file, take a look at the data file. It's like a little mantra. And because it's a CSV file, all the columns aren't necessarily, efficient. But I want you to notice like the kind of data that's in here. So is it an adult movie? Does it belong to a collection? Like, is it part of a bunch of different movies? What was their budget? Their genres? And it goes over and over again. IMDb ID number, language, title, overview, a plot. A picture to the a pathway to the image for the poster, etc. Who put it together, and the data just goes on and on and on, right? But you'll notice that there is at the far end here, there's some data columns like what people voted it, and this is on a 10-point scale. This is IMDb, right? So this is a rating scale from an independent website, and how many people voted on it. And so that's pretty pertinent information. All right, other pieces of data. the ratings. I'm going to use the small one. All right, so that one's opening up too. And notice that this, has a timestamp. So this, whatever that means, like when the data was taken, but it shows a user is, choosing it. They're using the movie ID. So in order to find what movie that is, you have to look at the other table to find the movie ID, right? And then the rating that they gave it with notice this is a 5-point scale. It goes from 1 to 5, and then when it happened, right? So these are real user ratings, and these aren't fabricated, by the way. It's a real data set, by the way. Okay. But this is the kind of thing you do, right? You have to look at the data and try to figure out, okay, what is in these data sets. And now we're opening up this one. I'm not doing a conversion on it once again. And here we have a movie ID, IMDb ID, and whatever the other one is. So these are all like little cross references basically for the data. And I don't need to alter any of it. But these are the data files you're working with. This ratings data set is huge, absolutely huge, but this is the one I want you to use for your homework, but make sure you can get it to work with this one first. That's the whole point, right? Now, the sample in the notebook contains that. Now, when I was putting the assignment together, and I did alter it a few times as I was doing it, and you know what, if I'd make any more alterations, I'll let you guys know. But basically what we're going to do is we're going to take first and look at the sample notebook that comes with. Okay, so in the dependencies, and I'm just going to open it up right now really quick. I am going to open it up with Visual Studio Code. I still have not solved my Anaconda problem, by the way. And because of that, and I'm just going to say this, I might abandon that project because I feel so unhappy with it at the moment. But all the code's broken down. You have clever little graphics with Homer in them, with explanation. So please read through this stuff. What I'm hoping, depending on how much time we have next week, is maybe I can demonstrate this, or I'll record a standalone video with it. Or if you get stuck on any of this, please reach out. They go through and they connect up the data, and I forget where they do that here, right? So they're using the movie's metadata file, right, as one of the core pieces here. And then they're going through the matrices. They do the cosine similarity, and then do a few other things. And then they start pumping in data. So in other words, if you watch The Godfather, what are other movies you should watch? Well, Godfather Part 2 makes sense, right? Godfather Part 3 does too. And then all these other ones. And if you know any of these movies, these are all like, mafia, organized crime movies kind of things, right? So what you're seeing here is we're taking this live data set that's provided by IMDb. We're running our algorithms, typing in a movie name, it finds something, and then it's using the data that's there. It's giving us recommendations. And we can tell from the Godfather one that makes sense. These make sense. And if you watch The Dark Knight, all of these make sense. These are all like superhero movies. Batman, right? It's like Batman. It's all Batman, right? Except for JFK. What does that have to do with it? All right. Then we get into collaborative filtering, right? So they share the code on how to do this. Notice that here's where they use the small rating file, and this is where you'll change it to make it the large rating file, right? It will take a lot more time to process, so be patient when you run it, right? It'll take like many, many more minutes than that. They do the SVD with the output. They do the hybrid recommender, and I know I'm going through this really fast. And then here's where I want to stop you, right? Because this is basically what we're doing, right? Is one of the things we did up above is content-based recommendation, and the other one is collaborative recommendation with the data sets that we're providing. One was on ratings, and one was from the movies like database thing. Okay, and these point you to specific data sets. And by the way, if you go to them, and I did this earlier, right? It's not there. So you can't use those, right? But the tasks are still the same. So if you read the assignment description, right, it says that you should do this, right? So and I'm going to read through all this so you guys are very clear on what you have to do, is go to Kaggle, right? And I'll go there in a minute, and find a Jupyter notebook, something that somebody's already created, right? And build that can be used for these two things. And people will label them, right? And then they also have a data set on Kaggle, and I'm going to open that up. And if you guys remember, Kaggle is like the world's like place where all us AI data science people kind of geek out and share stuff, right? Including data sets, models, code, etc. And they have courses and stuff if you want to kind of dig in. But here is the data set, and this is a little bit more updated. I don't know when it was put here, but they have more updated movie data here, and you can download this as a CSV file and take a look at it. All right. The other thing that's kind of interesting is whenever you look at a data set, you can look at the metadata, which means, by the way, metadata is data about data. It's kind of like a dictionary for the data. It tells us what data is in there, right? And then also there is a code area. So people have looked at that data, built code, and shared it. And you're free to look at these things and borrow from them. And in fact, I would encourage you to do that. It is kind of a deep dive, right? To look at other people's things. But if you have that wherewithal and time available or impetus, please do it, right? And you'll notice like right away, somebody's got a recommendation system for Netflix or whatever. And I would encourage you to explore these and see what you find is kind of what I'm putting out there. So if you can find even better data, more updated data, please feel free to use it and then alter it. However, and I realize that this might be a little bit overwhelming for some of you, but for others, it might be like, oh yeah, I'm into it. I'll check it out and try it because I have time to, and please do that. So once you found a notebook example, you can revise the code to work with the updated IMDb data, this one, or other data sets. If you don't want to do movies and you want to do, I don't know, cars, do that. That's fine. It's just a recommendation system. Or you can also use our sample code alter to complete the same task. So it says, and really, you see that this is redundant. So you guys are going to watch me fix that right on the fly here. Yeah, it's just that easy. All right. So optionally, you can revise the provided code and data in the dependencies for this unit to complete the same two tasks using the complete data, the large rating CSV file, right? Rather than the smaller one. So at a minimum, that's what I want you to do. And if you do that, you'll get all your points. Same procedures as everything else. You can work with AI if that's what helps you. I would recommend you stick really closely to that starter notebook. I might do some tweaking to this. I mean, you saw some of it happening. I don't know if I find a really killer data set and even example Python notebooks, I might adjust this and reshare it, right? This is not due until July 3rd. So it's like right before the holiday. So we still have time. It's 2 days after next week's class. And so if you get stuck or need help or whatever, and I'm going to throw this out there as well, if you find a better movie data set, share it. Let me know and I'll share it with the class. Or if you find a really cool Python notebook and want to tell me about it, I'm open to that as well. For those of you that haven't really explored Kaggle a lot, I'm going to really implore that if you haven't spent a lot of time here, that you start to change your mindset. They have a lot of really neat data sets and about all sorts of really weird stuff, that people keep data on and then share just for whatever. They also have models, and these are, and I want you to be really clear on this. These are AI models, usually large language models that you can borrow from. Some of the ones that are big and hot, and they're, folks, these are open source. If you have the computing power to run them, you could run them or look at them at the very least. People also share code, right? I'm just doing a really quick thing. And the other thing I'd like to point out too is there's discussions and everything, and the visualizations here are courses. So like, for example, this would be very appropriate for my data analytics people. This would be very appropriate. And this would, you know, so you got like courses here that you can take for free, right? They're not super deep, but it's there. So please explore. Now, somebody's posting that they're not seeing the assignment, and it is entirely possible. I never flipped the switch on it. So if that's the case, all right, it is now visible, and you guys have your assignment. And thank you for catching that. I appreciate it. I thought I had enabled it a day or two ago, but apparently not. And that's okay, because I don't want you rushing ahead if I have the potential of changing it, which is why I delayed it. So I'm going to say that this still holds, but we'll see. All right, I'm going to stop the video here, and we'll field questions or issues in the aftermath.